Yeah. I think like yeah. Wait, they just got it. Yeah. I just tried it myself.
Switching over like that.
Oh, I didn't put this one. Yeah. It should be working.
Yep.
Yeah, that's good. Awesome. Thank you very much.
You're welcome. Back to class, you guys.
Alright, so we're going to continue with the partial fraction integral. Alright, so let's just look at one example first. Continue. The first one we did is divide if improper, but that one it's okay. You can just use long division, synthetic division. Divide it will be okay. Second one I did the repeat linear function. No, wait, not this one. Let me just this one first. So 1 over x minus 2, x minus 3 dx. Okay, we solve this. We find this one. What do we do? We have to separate these two fractions. Write it as a x minus 2 plus b over x minus 3 dx. Next, we need to find out what is a, what is b. So we know that 1 over x minus 2, x minus 3 equals a x over 2 plus b over x minus 3. You know that a and b, you multiply everything by the LCD, which is x minus 2. LCD x minus 2 times x minus 3. So now you got 1 equals a times the other factor, which is x minus 3, plus b times the other factor, which is x minus 2. So now we solve that. Let x equals 3, solve for b equals 1. Let x equals 2, solve for a equals negative 1. Okay, it's pretty simple. We'll just review again very quickly. So we got that. We got a equals negative 1, b equals 1. Then the whole integral becomes negative 1 over x minus 2 plus 2 over x minus 3 dx. Okay, so first one is just a simple ln integral. So it's ln x minus 2 negative. And the second one is ln 2ln x minus 3. Wait, I don't have 2. It's positive 1. Okay, so it's ln x minus 3 plus c. Okay, then you can say ln x minus 2 minus 3. That's right, x minus 2, x minus 3. Okay, so this is how you do this one. Then we are done here. You can combine the two ln as ln x minus 3 over x minus 2. That's okay too. Okay, next one we're going to look at one more example, maybe two more examples. Okay, repeat linear factors. Repeated linear factors. What if I have 3x minus 4 x minus 1 squared dx? So can anyone tell me, if I decompose this fraction, what would my integral be? It would be which two fractions? Can anyone tell me here, if I decompose this fraction, it would be what? Very good. Thank you, Lacey. It's perfect. Okay. It would be x a over x minus 1 plus b over x minus 1 squared. Because this factor is repeated. Okay. This factor is repeated twice. So all the possible factors of this one is x minus 1. That's one of the factor. X minus 1 squared is another factor as well. So it has two possible factors. Okay. The b, you may say, oh, maybe we don't have this part. Yeah, you're right. But we still have a b here, even it's not there. even in the b is 0, okay? So we just have to make sure all the possible factors are out, then find the coefficient, okay? How do we find a and b is our next task, okay? What we do next is to find what is a, what is b. We still have x minus 1 squared 3x minus 4 equals x minus 1a plus x minus 1b squared. So how do I find a and b? We multiply everything by the LCD. LCD is x minus 1 squared. Then the left side is 3x minus 4. The other side is a times x minus 1. b you multiply by x minus 1 squared, cancel out, so it's just a b. Now if I let x equals 1, I can find out b equals negative 1. Then if I let x equals 0, plug in. So 0 minus 4 is negative 4 equals a times negative 1, so it's negative a plus b is minus 1. So you got a equals positive 3. Now my integral becomes two separate integrals, which is a is 3, so it's 3 over x minus 1. b is negative 1, so it's minus 1 over x minus 1 squared dx. Okay, so now I need a student to help me to finish this integral here. Okay, I'm going to call a student here. There, could you please help me here? Three ln x minus 1 minus okay, this one is a question mark. So since this is a polynomial function, is the negative 1, the ln only works for 1 over x form. But if it's x 1 over x squared changing to x to negative 2 power.
I think we can use this u substitution.
U substitution. Okay, so basically we can take it out, see what it is. 1 over x minus 1 squared dx, right? So you can change that into x minus 1 to negative 2 power, right? And then, let's say it's right, you can use u substitution. But this is a simple one. U substitution is not necessary, but it's okay. You won't make a mistake, right? So you do u equals x minus 1 du equals dx. You substitute is u to negative 2 du. And the answer is going to be... Thea, could you please tell me what this is? What negative 1? You press the button and it say, yeah, it's u to negative 1, right? And then over negative 1, very good. So the whole answer is negative 1 over u plus c. And then you can change the u back into x minus 1. So here, now this is minus, because we just finished this one. So it's minus 1 over x minus 1 plus c. So whole answer is 3 ln x minus 1 plus 1 over x minus 1 plus c. Okay, thank you very much. This is good. Alright, so that's how you do a fraction, partial fraction. First you decompose it two different factors, then we'll find a and b. Once you find a and b, then you take the integral on the two simple fractions, either ln or the polynomial function. Okay? Alright, so last time, question?
When plugging the 0 in, the x equals 0, why did we get a equals 3?
When x equals 0, you plug 0 into here, 3 times 0 is 0, minus 4 is negative 4, right? And b is given, b is given, so it's a times 0 minus 1 is a times negative 1, so negative a. And b is given as negative 1, so negative 1. And I solve for a. Because x is given, b is given, so only a is not given now. X equals 0 and equals 3. Does it make sense, Taylor?
Yep.
Okay. Alright, so next one, I think, did we finish last time? The complicated one? Did we finish it? That bit long one? Zijian, can you check your notes? Did we finish the last one on Thursday? Did we finish that one? The square root of 3. The final answer, which is ln x minus 2 minus half of ln x squared plus 2x plus 4 plus square root of tangent inverse of x plus 1 over square root of 3. Did you finish that one? Last Thursday. Well, that's a Friday. Oh, we did, yes. Friday we did that one first, then we do the homework. I remember. Alright, so next one. We'll just do one more. Now I think we're good. Okay. So repeat quadratic factors, but it's the same. But that's not really hard problem. Okay, this one. So example 4x squared plus 2x minus 1 over x cubed plus x squared dx. Okay, I would want you to try it first. Give you 2 minutes. 2 minutes, try it your best self. Yeah, let me give you a little bit of help. Otherwise, you will stop there. I can't continue. So what you need to do? First, you need to factor the denominator, because all the previous one you see is already factored. This one has not been factored out. So you have fact x squared out, x plus 1, 4x squared plus 2x minus 1 dx. So what do we have here? X squared is a repeated factor. So we have to write it as a over x plus b over x squared, because this one repeats twice. You have x and x squared plus c over x plus 1. I think after this you find a and b and c. Okay, continue. Okay, I think some student has done. Okay, let me. Has some student have probably have finished it yet? Okay, Nicholas, have you finished it?
Nope, not all the way.
Okay, since I see you are waiting, do you have any trouble? Which part you don't get?
So after you separated it out into the 3 parts right there, what am I looking to make x equal to find a, b, and c?
Alright, so now let's work together. I'll work it with you together, okay? So first, this and this should be equivalent for sure. So we just do 4x squared plus 2x minus 1, x squared, x plus 1 equals a over x plus b over x squared plus c over x plus 1. Does that make sense, Nicholas?
Yeah.
Okay, so next, what do you think I need to do? Nicholas, could you please tell me?
Well, we're trying to find a, b, and c.
Right.
So,
Yeah. The biggest problem is the denominator, right? The biggest problem, you have this, you have this, you have this, you have this. You have denominator, right?
right.
So what do you think we need to do?
Set x equal to something that'll make them go away.
We have to get rid of the denominator first. So is there any way we can get rid of all of them, all of the denominators?
Go least common denominator.
Yes, multiply everything by LCD. Multiply everything by LCD. What is the LCD?
X squared times x plus 1.
That's perfect. Okay, so we multiply everything by LCD. If I multiply the first term, this one by LCD, what I got?
X squared plus x.
I mean, I multiply this one by this, by the LCD. What do I have?
4x squared plus 2x minus 1.
Perfect. Okay, if I multiply minus 1, sorry. If I multiply the second one, multiply this one by LCD, what do I got?
Just x? No.
X into X
ax squared plus x.
A x squared and x cancel 1x, right? So this x will cancel with the 1 over the x squared here. So the ax times you have x plus 1 remained, right? Nicholas?
Yeah.
Okay, what about this one? I multiply the LCD on this one. What do I have?
X plus 1.
No.
So the x squareds go away, right?
Yes. So you have b times
X.
plus 1, right? Make sense, Nicholas? Okay. So what about this one? You multiply the LCD on this one.
Just x squared or cx squared.
Cx squared, perfect. Okay, next step, I would want to continue ask you. So what x do you want to think? Let x equals a special value to find any a variable here. So x equals what first? Nicholas?
0.
X equals 0, perfect. So if x equals 0, plug it in. So what I got for here, for this one?
-1.
-1. What I got this one?
0.
0. What I got this one?
B.
B, very good. What about this one?
C. Oh, 0.
0, because this is 0, right? So I got b equals -1, perfect. So what about next? X equals what?
-1.
-1, very good. Okay, so I plug this one, -1 into this first one. What's the number? 4 minus 1 minus 1. Just I do that.
Okay.
So this one, what about this one? -1.
0.
0, perfect. What about the second one?
0.
0, perfect. What about the last one?
C.
C, perfect. Okay, so I got C equals +1. Okay, so now what's next? I got 0, I got -1. I need to find out 8. I don't know what is 8. So x equals what?
It can be anything, right?
That's right. X can be any number. X can be just 1. We just choose 1. So we got is 4 plus 2 minus 1 equals 2 times A. I can't make it smaller. Okay. 2 times A plus 2 times B is given -1 plus C times 1 squared is C. So it's 1. Okay. I find A equals +3. So my finally I got the decomposition out as 3 over x dx. Just put them together. Don't want to work. -1 x squared. No, just minus 1 over x squared because b is -1, right? 1 over x squared. Plus c is +1, so it's 1 over x plus 1 dx. Okay, I still would like you help me. Okay, Nicholas, what would you this one be?
The natural log at 3 ln x, right?
That's perfect. Yes. What about this one? So it's x to -2 power, and then plus 1 is x to -1 power, divided by -1. So it's just x to -1. Make sense?
Yeah.
Yeah. Because it's -x to -2, you do the antiderivative, so it's going to be negative x to -2 plus 1 is -1, divided by new power is -1. So the answer is going to be negative cancel is the x to -1 plus c, which is just 1 over x plus c. Okay. This kind of this one, you should have to do this quick. Okay, next one. How about this one?
Natural log of x plus 1.
Natural log x plus 1. Perfect. Thank you very much, Nicholas. You did a very good job. Okay, plus c. Now we're done with this. So everyone, are you good with it? Good? Okay, very good. So this is the key. This is the steps what you need to do. First, you factor the denominator and write it out as the ABC form. Then find ABC, multiply the LCD, then you name x as a special value, plug it in, find ABC. Then use basic rules to find the antiderivatives. Okay? Alright. Let me see. Repeat quadratic factors. I want to try one more. X squared plus x plus 3, x squared plus 3 squared dx. Can you try this one? Alright, I hope you don't have any trouble with writing down the forms first. So, this one could be decomposed in two fractions. Can anyone tell me what do you think the factors would be, the fractions?
A over x squared plus 3 plus b over x squared plus 3 all squared.
Alright, so Lacey says it's x plus 3 squared. Any different answers? Anyone else? Do you have a different opinion? Richard? Zijian? Press the button if you answer the question. Press the button. Okay, Zijian thinks the same. Okay, I will ask another student. How about Taylor? What do you think? Do you think the same?
I'm actually not too sure about this one.
Okay. Okay, let me ask another student. Jasper, do you think it's the same?
I'm not sure.
Luke, do you think it's the same?
Well, I think there's probably another factor based on how you're asking us all, but I don't know what it is.
Okay, this is a quadratic form. This is x squared plus 3. It's not a linear form. It's a quadratic form. So the factor, if it's a quadratic form, the factor would be ax plus b. Okay, this is another quadratic form again, so just cx plus d. Right? Whenever you see a quadratic form, the numerator is ax plus b. Okay, they always like that form. So this is a quadratic form. Okay, linear form ax minus b. If it's the first linear form, the numerator is just a, b, c, d, like those. If it's a quadratic form, it's ax plus b. Alright? Does it make sense, everyone? Good. So now our job is finding the a, b, c, d. Okay? What do we have? Is x squared plus 3 square x squared plus x plus 3 equals x squared plus 3 ax plus b plus x squared plus 3 square cx plus d. Okay, so since Lacey has answered my question here, Lacey, would you please tell me, continue, how would I find a, b, c, d?
I think we're gonna multiply through by the lowest common.
Yes, what is LCD?
X squared plus 3 all squared.
Okay, so if I multiply this by this, what you got?
X squared plus x plus 3 equals equals ax plus b times x squared plus 3 plus cx plus d.
That's perfect. Okay, so now, what do I do here?
I think we can let x equals 0 first.
X equals 0, we have b and d.
Okay, I think we can actually like expand and compare like coefficients.
Oh, that's a very good answer. Yes, we can do special numbers, like x equals 0, x equals 1, x equals 2. You're going to solve a linear equation system instead of one equation, okay? But this is a very good idea. You FOIL it out, okay? You FOIL it out. You got ax. Could you please continue?
Ax cubed plus 3ax plus b x squared plus 3b plus cx plus d.
That's perfect. So what's next?
So ax cubed is going to be equal to 0.
That's right.
There's no. Then I have bx squared equals 1.
Mm-hmm.
And then I have 3ax plus cx equals x, and that's 1. That's 3a plus c equals 1.
Mm-hmm.
Then I have 3b plus d equals 3.
Mm-hmm.
So from b equals 1, I can put that in the last one and add d to be equal to 0.
That's very good. We'll find A, B, C, D. Thank you very much, Lacey. You did a really good job. Okay, here I've never explained that you expand this and match the coefficient. Okay, this is another method. I would want you to do that as well here. Lacey mentioned this one is really good, and this is what I'm going to do, but I'm going to explain. But she did a really good job here. Expand this and you can match the coefficient. Instead of doing that, solving A, name A and do A, B, C, D and find a special value, find A. That the matching the coefficient also works for the other one as well. Okay, even for another one, for example, you have x minus 1 equals a, x plus 1 plus b, x minus 1. Like this kind of thing, you can also do the match coefficient, okay? You can also do that as well. But this one specifically is much easier if you do the matching the coefficient, okay? You still can do let x equals 0, let x equals 1, let x equals -1, let x equals +2. You need 4 numbers, and you have 4 different equations and solve that A, B, C, D. Okay. Sometimes when you're lucky, you probably will have 2 and 2. Okay. So that's a really good idea to match the coefficient here, and then we find A, B, C, D, which is perfect. Okay. Does it make sense, everyone? Do you have any questions here? Okay. So now you got the derivative is going to be x squared plus 3, a equals 0, b equals 1, ax plus b, so it's just 1. Cx plus d, c is 1, so it's just 1x. D 0, and then the denominator is x squared plus 3 square dx. Okay, so This one, I just do this 1 over x squared plus square root of 3 square dx plus another one x squared plus 3 square dx. Okay, so here I would want a student to help me with this antiderivative. How about Eric? Can you tell me with this? Can you help me with this one?
Are we going to use trig substitution?
Yeah, we can use trig substitution, but this is a normal one we see a lot before. So 1 over a squared plus x squared dx inverse of x over a. So now can you finish it?
So 1 over square root of 3.
1 over square root of 3, very good. Then
Arctangent of x over square root of 3.
arctangent over x over square root of 3. Okay. Do you have any idea about this one?
U equals x squared plus 3.
Very good. U equals x squared plus 3 and du equals 2x dx. And then we can... Okay, now since you mentioned that u, so can you continue with that? I did this.
Okay, so plug it in so that the x on top cancels and we can pull a 1/2 out front.
Yes. So du 1/2 in the front. Very good. So 1 is the u squared, right? So now the final answer is going to be tangent inverse of x of square root of 3. And then this is a half of what? Half of Eric?
Negative 1/2 of 1 over x squared plus 3.
Negative 1/2 of 1 over, that's perfect. Negative 1/2 of 2 and then 1x plus 3 squared plus c. That's perfect. Very good job. Okay, thank you very much. I think most of students should be fine with this kind of problems right now, right? Find a. First, you decompose it, break it into two different fractions. If it's a quadratic form, use ax plus b. If it's a linear form, just use a, b, c, d, and find out the coefficient. Then use the very basic integral rules, and then we're fine. I will assign more practice homeworks in your homework 6. Give you more problems to do. So next we can do a little bit of 8.6. So integration by tables. Integration by tables. Well, in this section, I have to give you the formulas. I give you the formula. You have to use the formula to do the antiderivative. There is not much of like integral skills in this one. You just have to apply the formulas to solve the integrals. Okay. Most of the integrals are kind of the hard ones, and the formula is really long ones. So first one, x squared over 5 plus x dx. Okay, the formula table. Don't worry about this. If I give you the integration like this, if I give you any derivative like this, I will give you the formula for sure. There's no way you can memorize those long formulas. Okay, so formula is u squared a plus bu du equals 1 over b cubed negative bu over 2a minus bu plus a squared ln a plus bu plus c. Okay, so this is the table, or this is the formula. So now since the formula is given, I would want a student to help me to finish this final result. So whenever you have the formula have A and B's, the best way for you to do, you match it. See what is A, what is B, then you won't make the mistake. Okay. So here, I want a student to tell me what is A, what is B. Bella, could you please tell me what is A, what is B here?
Is 5.
A is 5. B is X is U. B is what? 1. Very good. Okay. Since you said A is 5, B is 1, then which is right? Perfect. Could you please help me plug into this formula as well?
I'm still trying to copy it down.
Okay. No problem. Once you're done, please continue.
Okay.
Okay.
1 over.
Okay.
1x.
So,
Minus.
so what did you say? 10
Yeah, 10.
minus. Actually, this is not a absolute value. It's just a parenthesis because there's no ln here. Okay. So, all right. What's next, Bella?
5 squared.
5 square.
5
X. Perfect. You did a really good job. Thank you very much. Okay. So what do we do? 1 over 1 is 1, so we don't have this. It is 1 times itself is itself. A negative 1/2 is negative 1/2. Okay. It's negative half of x and 10 minus x plus 25 ln 5 plus x plus c. Okay. So here there's not really a much math skills here. Is once I give you the table, you know how to apply the table into solve the real integrals. Okay. So next one, second example. Square root of x squared minus 36 over 6x dx. Okay. Also, I give you a table formula. Okay. Is square root of u squared minus a squared over u du. Maybe I just use x, then you can directly match the x. You don't have even worry about what is u, what is x, right? So u squared minus a squared minus a arc secant u over a plus c. Alright. So here I would like to ask another student to help me here. Matthew, could you please help me to finish the integral here?
Alright, so the square, so I should start from just like after the equal sign?
Yes. You just need to plug in. The 6 you can take it out, it's 1 over 6. So this 6 is actually the coefficient, is 1 over 6. You don't have to worry about that. You just match this two.
Alright, so it'd be the square root of like x squared minus 6 squared, right?
Very good.
Minus the 6 arc secant of the absolute value of x over 6, right?
Yes. Perfect.
And then plus c.
Yeah, thank you. Perfect. Matthew, thank you very much. You did a very good job. Okay, so this is the final answer. Will that be good, everyone? Okay, this whole section is, we can do a little more examples, but I'll give you more formulas, look at more examples tomorrow. I think we should be okay, given the formulas, and then we do the antiderivatives, this section is not really math skills. Most of them should be okay. Okay, so I'll see you tomorrow, and we'll continue finish this one and see if you have any questions, and then we're gonna move on. So far, everyone is doing very good job. Thank you very much. I'll see you tomorrow.